the last two videos, we looked at the language of hypothesis testing, and in particular looked at examples of how to state the null and alternative hypotheses. We'll look at one other idea, which is the possibility that you could get two kinds of errors called type 1 errors and type 2 errors. We'll start with an example to illustrate the meaning of a type 1 error and a type 2 error. And this introductory example is similar to 10.1 numbers 17 and 19 and 21. Suppose that you are an astronaut and you have recently been selected by NASA to be part of the first mission to Mars. A week before launch, NASA physicians will give you a blood test to assess your health. If the blood test finds more than 200 viral particles per milliliter, you likely have the flu and cannot continue with the mission. If mu, let's say mu is the population mean, if that represents the actual population mean concentration of flu virus in your blood, then the following hypothesis would represent your health. The null hypothesis would be that the actual concentration of virus particles is 200 or maybe less, which would mean that you're probably healthy. The alternative hypothesis would be that the mean concentration of virus particles in your blood is more than 200, which would indicate that perhaps you are not healthy, perhaps you have the flu. Suppose that your blood test is positive. In other words, it reveals you have more than 200 viral particles per milliliter in your blood. This would mean that you are likely not healthy and you have the flu. On the other hand, even though your blood test is positive, it is possible that your test result is incorrect and that you actually do not have the flu. It's always possible for a medical test or other kinds of experiments to give you a result, and that result may not reflect what's actually reality. Let's take a look at all possible test results in combination with all possible health outcomes. In this table, these rows represent reality, and the reality is that either you're healthy and you don't have the flu, or you're not healthy, meaning that you have the flu. And then these columns represent the conclusion of your test, of your blood test. So one outcome of the blood test is that you get a positive result, and if that were the result, you would say that you reject the null hypothesis. You're rejecting this, and you would conclude that the alternative hypothesis is true, meaning that perhaps you have the flu. And again, that could be the correct conclusion. That might match up with reality, but there's always a chance that that result is inaccurate. And even though you get this result, a positive blood test, you actually are healthy and you don't have the flu. And in that case, they call that a type 1 error. In medicine, sometimes they call that a false positive. You get a positive blood test saying that you have some illness, but that test is actually wrong, and you actually don't have that illness. So in statistics, that's called a type 1 error. This other column would be the possibility that your blood test comes out negative. You get a negative result. If you did, you would say that you do not reject the null hypothesis. So it's kind of like an indirect way of saying that you are accepting this null hypothesis to be true, that you're probably healthy. And you would conclude that the alternative hypothesis is not true. In other words, that you do not have the flu. If you really do not have the flu, if that's the reality, that you're healthy and you don't have the flu, then that test result is giving you the correct conclusion. But if you get a negative test result and you actually are not healthy, you actually have the flu, that would be called a type 2 error. And in medicine, they sometimes call that a false negative, meaning that the blood test indicates that you do not have some illness, but for whatever reason that test missed the illness within you, and you actually do have that illness. And that can happen in every test or experiment. There's a chance that that could happen. So that is what a type 1 and a type 2 error would mean. Here are the definitions for type 1 error and type 2 error. A type 1 error is when a study's results lead researchers to reject the null hypothesis and conclude that the alternative is true. But the study's results were incorrect, and in reality, the alternative is actually false, and the null is actually true. A type 2 error is just the reverse. So that's when a study's results lead researchers to not reject the null hypothesis and conclude that the alternative is false. But the study's results were incorrect, and in reality, the alternative is actually true, and the null hypothesis is false. Here's an example to, again, describe type 1 and type 2 errors. Nature's Quest is a company that sells natural and alternative health products. In 2018, the company claimed that its ginger root tablets were effective in relieving headaches within an hour for 80% of users. A consumer advocate doubts these claims and suspects that the proportion of ginger root users who experience headache relief within an hour is significantly less than 80%. The consumer advocate then sets up an experiment to test the company's claims. So part A says write the null and alternative hypotheses. The first thing that we'll want to note is that in this problem, the parameter that is being referred to is the proportion. And we'll use P to represent proportion. P in this case is going to represent the unknown, and the unknown is the true population proportion of ginger root users who experience headache relief within an hour. The null hypothesis is that the proportion who experience relief in an hour is just what the company claims. It's 80%. The alternative is the belief of the consumer advocate. The consumer advocate believes that this proportion is significantly less than 80%, less than what the company is claiming. And so in symbols, that would be that the true proportion who experience headache relief is less than the claim of the company, less than 80%. So here is the hypotheses. Part B says, what would it mean for the consumer advocate study to make a type 1 error? A type 1 error in general is when your study leads you to conclude that H1 is true, but your study's results are incorrect and actually H0 is true. So let's put that into context. A type 1 error would mean that the study's results lead the consumer advocate to conclude that less than 80% of ginger root users experience headache relief. In other words, to conclude that the alternative hypothesis is true. But in reality, the proportion of ginger root users who experience headache relief is actually 80%, as claimed by the company. In other words, actually, in reality, the null hypothesis is true. Part C says, what would it mean for the consumer advocate study to make a type 2 error? So a type 2 error, in general, would be if your study's results lead you to conclude that the null hypothesis is true, but your study results are incorrect and actually the alternative hypothesis is true. So to put that in context, a type 2 error would mean that the study's results lead the consumer advocate to conclude that the proportion of ginger root users who experience headache relief is 80%, just as is claimed by the company. In other words, to conclude that the null hypothesis is true. But in reality, less than 80% of ginger root users experience headache relief. In other words, the reality is that the alternative hypothesis is actually true. So one takeaway from this section relates to type 1 and type 2 errors. And you want to keep in mind that type 1 and type 2 errors are not necessarily the result of any wrongdoing on the part of the researcher. Rather, type 1 and type 2 errors are the result of the following facts. So, for one, no one study is definitive in its conclusions. And secondly, it's always possible that a study's results can make incorrect conclusions about reality. Any one study, any one result is important, but there's always a chance that it can be wrong.